Hi all, this is Vasily from Atom Tuition. Let us see how to prove few problems, like proving problems I've taken using the tangents, okay? Something related with tangents. So here's the first question. Two tangents TP and TQ are drawn to a circle with the center O from an external point T, okay? Fine. So the center of the circle is O and the external point is T. From the T you're going to draw two tangents like TP and TQ. You need to prove that angle PTQ is equal to twice the angle of OPQ. Okay. So let us first picturize this. Now you need to prove PTQ. Which is PTQ? This angle is PTQ. You have to show that this angle is equal to twice that of OPQ. OPQ is this, okay? So I just take this angle as X. So this angle X, you need to prove that it is twice that of this OPQ, okay? Fine. So I have just drawn this. First, let us do one thing. Just take the triangle TPQ, okay? TPQ. Let angle PTQ be X. I have taken that as X. Since TP and TQ are tangents, I can say that TP is equal to TQ, right? So, TP is equal to TQ, okay? So, because they are tangents, okay? They are tangents from a external point, from the point T. Got it? So, they are equal. Fine. So, what can I conclude? Therefore, I can say triangle TPQ is isosceles, right? Yeah, it is isosceles triangle. That implies, since they are isosceles, the base angles are same. Angle TQP should be equal to angle TPQ, okay? And that should be equal to, in a triangle, the interior angles are to be 180, right? I just take away this X, which we know from 180, and then divide the rest between these two angles, okay? So I write that here. This should be 180 minus X, that is that angle T, divided by, and divide that among these two angles, okay? So this I can write it as 180 over 2 is 90 minus X over 2, okay? So I just take this as equation 1. Next, I can say that this angle, that is TPO, is a right angle triangle, right? Because it is a tangent, it is an angle formed when a tangent and the line from the center, the radius, meet. So it is a 90-degree angles. Since angle TPO is equal to 90-degree, because that's an angle formed by the radius and tangent, okay? So that is 90-degree. I can say, since this is 90-degree, we can say angle O, that is what we need to prove, right? OPQ. Angle OPQ should be equal to TPO minus TPQ, right? TPO, that is the bigger angle, minus angle TPQ. Got it? I repeat, angle OPQ is equal to TPO, take away TPQ. So we get this small angle, okay? So OPQ is equal to TPO is 90-degree, okay, since it is perpendicular. Take away TPQ. TPQ you got it as 90 minus X over 2, right? So When the minus gets inside, it becomes 90 minus 90 plus x over 2. Okay. So your plus 90 and minus 90 will get cancelled. So you got your OPQ is equal to x over 2. So you can just take this to the other side. Multiplying both sides by 2. What do you get? You get 2 angle OPQ is equal to x, which is nothing but angle. What did we take as x? It is TPQ, right? So this implies angle TPQ is equal to twice angle OPQ. Hence it is proved. It's very simple, okay? Proving this is very simple. Okay, now let us see the second problem. Prove that opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay, let me first put the diagram here. I have just taken a circle and the quadrilateral is circumscribing, right? A circle. That means the quadrilateral should be outside the circle such that all the sides of the quadrilateral touches the circle. Okay. So those points I've just marked it as P, Q, R and S. The quadrilateral I have named it as ABCD. The quadrilateral is ABCD and the point at which the circle and the quadrilateral touches each other is PQRS. I have marked that too. Okay. And here they ask you to prove that the opposite sides of the quadrilateral circumscribing a circle subtend supplementary angles. That is, say for instance, I just name it as O here. So we have to prove that the angle AOB is equal to the angle COD. Okay? Or you can say AOD is equal to BOC. Angle AOB and angle COD. Okay? Both are supplementary angles, right? That's what they ask. So BOD together should give you 180 degree, or you can prove this, or you can also say angle AOD plus angle BOC is equal to 180 degree. So if you just prove one of it, that will do. So for this, what I do is, first I have just joined the OA, okay. Now I get two triangles here like AOS and AOP, okay. In triangle AOS and triangle AOP, okay. In these two triangles, let us see how we can prove the congruency, okay. So here you have OP and OS. OS is congruent to OP, right? Because they are the radii. The reason is they are the radii of the circle, okay? So all the radius of a same circle are always equal. So OS is equal to OP. And then you have AP and AS, right? So I say AS is equal to AP because they both are the tangents. Just look, this A is a point outside the circle and AS and AP are the tangents to the circle, right? So I can say because they are tangents from point A, okay? So they must be equal. And then you have OA is equal to OA because that's a common side, right? OA. So that is common side. So you find that the three sides of these two triangles, the corresponding three sides are equal to the corresponding three sides. The corresponding three sides of AOS and AOP are equal. So I can say, therefore I can conclude that triangle AOS is congruent to triangle AOP. Okay, so this angle, okay, this angle here I am marking. I just take these two angles, I just put 1 and 2. Okay, so I can say angle AOS, right? AOS is equal to, congruent to angle AOP. Here the reason is SSS criteria, okay? SSS congruency, and this is CPCT. This implies that angle AOS is equal to angle AOP, CPCT. Got it? The corresponding angles, right, of the congruent triangles. Okay. Now you got this, 1 is equal to 2, right? Likewise, I'm going to draw lines here, okay, a dotted line here, and this I take it as 3 and this angle as 4. So similarly, I can say similarly, so this is angle 1 equals angle 2, right? So similarly, you can prove that angle 3 is equal to angle 4. Okay, then yeah, when I join these two, so this is angle 5 and just imagine this is angle 6. So I would say angle 5 is equal to angle 6, right? The same way you can prove these. And finally, you have the last triangle like SOD and ROD, right? So these two are same. So I just write it as 7 and 8 here. So and angle 7 is equal to angle 8, right? Now what we know is, when we add all these angles in the center here, these central angles, if you add, it should give you 360 degree, right? Because one full circle is 360 degree. So this implies angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 plus angle 6 plus angle 7 plus angle 8, this should be equal to 360 degree. So since angle 1 and 2 are same, I can write these two are same, right? So this I'll write it as twice angle 1, okay? 3 and 4 are same. So I'll write 2 times angle 3, okay? Now, these two are same, 5 and 6 are same. So I write this as 2 times angle 6, okay? I tell you why I'm not writing angle 5 and why I take angle 6, because I'm going to prove these two angles, okay? AOB and COD. So I'm just taking the angles which come under these two. So here 2 and 3 comes, and here it is 6 and 7. So here instead of angle 1 I take it as angle 2, okay? And here this is 2, these two are same, right? So this I can write it as twice angle 7 is equal to 360 degree, right? So what we can do is take the 2 common out. So this is twice angle 2 plus angle 3 plus angle 6 plus angle 7, right? Is equal to 360 degrees. Now divide throughout by 2. You get angle 2 plus angle 3 plus angle 6 plus angle 7 is equal to 180 degree. You are dividing both sides by 2, okay? What is angle 2 and angle 3? It is nothing but, when you look at the picture you will know, angle 2 and angle 3 is AOB, right? So this is angle AOB plus angle 6 and angle 7. Just look at it. It is the opposite angle here. It is COD, right? So that's angle COD is equal to 180 degree. So they just wanted this only. See, the question is to prove that opposite sides of the quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle. So you have proved it here. So similarly, you can say, you needn't write all again. You can say similarly angle BOC plus angle AOD will also be 180 degree. Okay. So hence it is proved.